Welcome to Pomodoro Joe for Thursday, July 27th, 2023. Today we're looking at LeetCode problem 2141, maximum running time of n computers. This is a hard problem. You have n computers. You are given the integer n and a zero-indexed integer array batteries, where the ith battery can run the computer for batteries index I minutes. You're interested in running all n computers simultaneously using the given batteries. Initially, you can insert at most one battery into each computer. After that, and at any integer time moment, you can remove a battery from a computer and insert another battery any number of times. The inserted battery can be a totally new battery or a battery from another computer. You may assume that the removing and inserting process takes no time. Note that the batteries cannot be recharged. Return the maximum number of minutes you can run all n computers simultaneously. All right, this is tricky. So let's take a look at one of these examples. All right, so we have 2 computers and 3 batteries, and each battery has capacity 3. So you might think, well, I'll just put one battery into each computer and we get 3 minutes total. And then that's our return. We return 3 minutes. But they're putting 4 as their output. So how do they get 4? All right, so initially, they insert battery 0 into the first computer and battery 1 into the second computer. So that's 2 batteries of capacity 3. All right, after 2 minutes, they remove one of the batteries from, looks like they're removing battery 1 from the second computer, and they insert battery 2 instead. So we've gone 2 minutes, our 3 capacity batteries are now down to 1 minute left. You pop out one of those batteries and pop in another battery that has 3 minutes of capacity. So now we have a 1 capacity battery in the computer and a 3 capacity battery in the other computer. Note that battery 1 can still run for 1 minute. Okay, at the end of this 3rd minute, then we can remove the depleted battery, battery 0, and you can pop in this reserve battery that we had with 1 minute remaining back into that computer. So again, we start with 2 capacity 3s. They both go down to capacity 1. We pop out one of them. So we have this reserve battery with capacity 1, and we pop in a capacity 3 battery in its place. We get 1 more minute out of that battery. Now we have a depleted battery, and then a battery of 2 still in one of the computers, and this reserve battery with 1 left over. We can pop that in, and we get 1 more minute. So at the end, we get 4 total minutes. Oh man, so this has to do with popping batteries in and out. This is tricky. All right, so here's the plan. We will basically start with all the best batteries we can. We'll sort our batteries. We'll take the top n batteries, so the batteries with the most possible capacity. That's our base case. We're gonna stick those in there. At best, we'll get the, smallest batteries capacity worth of time. So we sort our batteries, take the top n batteries. Currently, our smallest of those top n batteries is our limiting factor. That's going to be the amount of time we can get out of all the rest of the batteries. All right, all the other batteries that we have, so the batteries that aren't in this top n battery pack, those batteries are our extra capacity. That's our reserve. Now, this shows us that we can sort of swap these in and out, even if there's just 1 minute left on a battery. So that means that all these batteries in our reserve, we can basically use those to their maximum use. We can pop them in and out and basically get every last minute out of those batteries. So those batteries, those extra batteries, we can treat that as like a pool of extra capacity. We don't need to treat them as individual batteries anymore because we can pop these in and out. It's more like just a pool of capacity, some time, that we can add to our other batteries. So that's the plan. We're going to start with the top n batteries, and then we want to try to equalize our capacities such that we get the best result. So we'll take the smallest battery, and we're going to try to get that battery's capacity up by taking some of our extra capacity out of the pool of the other batteries. So we'll grab some of that capacity, we'll add it to our smallest battery, bring that capacity up, and that will increase our return value. So we bring that battery up, we get a better return value. So how much do we bring it up? Well, we could bring it up all the way. We could basically take the entire capacity, extra capacity, add it to our smallest battery, but that might way overshoot. That might make it the biggest battery or the largest capacity, which makes our limiting factor now the second smallest battery. Then we have to do the same with the second smallest battery, but if we used up all our extra capacity, there's nothing we can do with that extra smallest battery. So what we really want to do is take whatever extra capacity that we have, add it to our smallest battery, just to bring it up just enough to reach our next smallest battery. Now we'll have two batteries at the same level, and that will be our new smallest level. If we have any extra capacity after that, we can try to raise both of those batteries up to the next smallest battery. So we keep raising up our smallest batteries until we have essentially a level playing field. We're trying to level out all these batteries. In the end, we might have some extra capacity that we can't distribute among all the other batteries, but we'll just do our best. All right, so that's the plan here. So we'll put 25 minutes on the Pomodoro timer and we will get started. So I think the first thing I want to do is just make sure, do we have enough batteries for all of our end computers? So the length of our batteries, if this is less than n, now we don't have enough batteries for all of our computers, so we can just return 0. Okay, what else do we want to do? Well, we want to sort our batteries. So we'll sort the batteries. This will be from low to high. So our top performing batteries, or our top capacity batteries, will be at the end of our array here. So let's have sorted batteries. All right, so our sorted batteries will sort from low to high. So our best batteries are at the end of our array. Now let's do one more check here. We might not have any extra batteries. We might have just enough batteries for all of our computers, which means our limiting factor, or the smallest battery, is our best answer. There's nothing we can do about it. So let's do another check here. So if the length of our batteries, the number of batteries we have, is the same as the number of computers that we have, then the best we can do is that smallest capacity battery here. So we'll just return sorted batteries at index 0. That's the best we can do. Otherwise, we do have some extra battery capacity. We have these extra batteries. As I mentioned before, we can treat these batteries as just a pool of capacity. So let's calculate our pool here. So the extra battery capacity. Well, that's going to be the sum of all of these extra batteries. Okay, so our extra battery capacity will be the sum of our sorted batteries up to, but not including, negative n. So negative n is just the nth from the end. So our top n batteries will be used as our initial batteries for our n computers. All right, so we'll sum up to, but not including, negative n. This is our extra battery capacity. All right, so then what's next? Now we will find our smallest battery and try to increase its capacity to some target. Now that target battery will be the next battery up in the list. So let's find our start index here. This is our starting battery. So that's just the length of our batteries minus n. All right, so this is our very first, or the smallest battery that we have installed in a computer. And what's our target index? Now our target index will just be the next battery up. So that's the start index plus 1. Okay, so we're trying to take our smallest battery at this start index, and we're trying to reach its capacity, or increase its capacity to be the same as the battery at the target index. So that's just the next battery up, the next highest capacity battery. All right, so let's say while we still have some extra battery capacity, let me just copy this. So while we still have some extra battery capacity, while it's greater than 0, and while we're not outside of our range, so we want to make sure that our target index doesn't overflow our bounds. So while this is less than the length of our batteries, now we can try to find our target capacity. So I'll just call it target value. Well, I'll call it target capacity. I think that's good. So our target capacity will now be the capacity of the battery at this target index. So that's going to be our sorted batteries at the target index. All right, so we're choosing a battery as our target, the target capacity we're trying to get to. And we're going to make that the second to smallest battery. So the smallest battery is our limiting factor now. We want to take that battery up to the next to smallest battery capacity. So that's our target capacity. All right, so we're looking at one battery up from the smallest capacity. That's our target. Do we have enough battery capacity in our extra battery capacity to actually increase our current capacity up to this target? Well, let's find out. So let's keep track of our current capacity. Let's actually start that out here. So our current battery capacity will just be the capacity of this current or start battery. So that's sorted batteries at the start index. All right. So now we've got our target capacity and we know the current capacity. We can find the delta. Let's find the difference between the two. Okay, in order for us to get our current battery up to the level of its target, we need this delta. That's how much of this extra battery capacity we need to use. So let's see if we have that. If we don't have that, then we're done. So let's see if our extra battery capacity, so if this extra battery capacity is less than or equal to this delta, then we don't really have enough to get to that next target. But we do have enough to get us a little bit more. So we can actually just return our current capacity plus this extra battery capacity. That's as much as we can give it. That's the best we're going to do here. So we can just return our current capacity plus whatever extra battery capacity we have. Now, it won't reach to the target, but it will get us a little bit closer to our goal. So that's the best we can do. All right. Now, if we do have enough capacity, we have enough extra battery capacity, well, then we need to update that. We'll take some of this capacity out. We'll add it to our current capacity. So if we make it this far, we do have enough. So then our current capacity can be increased by this delta. So we're going to take this delta out of the extra battery capacity and add it to our current capacity. But that does mean that we need to update our extra battery capacity here by subtracting the delta. All right, so we're going to take some from the extra battery capacity. We'll add it to our current battery. That makes sense. Now we'll also go to our next target. So our target index will increase by 1. We're looking ahead to the next battery and make that our new target. So this looks pretty good, but there's one problem here. Once we've added some delta to our current capacity, now when we go to the next target, so we look forward to the third to smallest battery, we have some new target capacity. When we get to that new target that we're trying to reach, now at this point, we no longer have just one battery at our current capacity. We've got 2 batteries at the current capacity because we've raised the smallest battery to the second smallest level. Now we have those 2 batteries, the smallest battery raised to the second smallest level and the one that was already the second smallest battery. So we have 2 batteries that we're trying to raise up to the third to smallest battery. So we have 2 batteries we're trying to raise to the next target. So that means this delta has to be doubled. We need twice this delta in our extra capacity because we have 2 batteries that we're trying to add delta to. Oh man, so this gets complicated. So we still keep our delta, but now instead of just checking if we have enough capacity for 1 battery to increase by this delta, we need to increase 2 batteries by this delta. So we actually need to keep track of how many batteries there were. Okay, so we need to keep track of how many batteries we're actually lifting up to these next capacity levels. So let's keep a battery count here. Let's see. I guess I'll call this, what will I call this? Oh, actually, wait. We don't need to actually keep it. We already have these indices. So let's have this battery count. Should I call it battery count? What's a good way to call it? Or current capacity? Yeah, I'll call it that. Current capacity battery count. So we have a target capacity. We have this current capacity battery count. And that's just our target index minus our start index. So now we're trying to raise that many batteries up to this target. So we have our target capacity, and then we have the number of batteries that we're trying to raise to that capacity. And that's just our target index minus basically how many batteries came before this target index. So that's the target index minus the start index. All right, we can keep our delta, but we now need to use this delta to raise a certain number of batteries. So we have to multiply this by the current capacity battery count. Okay, so So now the total delta we're looking for, actually maybe I should use total delta. Yeah, I'll do that. Let's do that. So the total delta we need, that's delta times the number of batteries. All right, so now in here, if our extra battery capacity is less than our total delta, then we can take our current capacity and we actually have to divide the extra capacity up among the number of batteries that we have. So we'll have to do the extra capacity divided by this current capacity count. And I'm doing an integer divide here. So we've got 2 batteries, 3 batteries, however many batteries we're trying to raise up to that next level. We can take this extra battery capacity and just distribute it evenly among all of these batteries we're trying to raise to the next target. If we're able to raise all the batteries to the next target, then we have to reduce our extra battery capacity by our total delta, because we have to divide that among multiple batteries. But our current capacity only gets to increase to our new target. So actually, let's make this, instead of plus equals delta, our current capacity just equals our target capacity. That makes it a little bit easier. All right, if we have enough extra battery capacity to increase all of our batteries up to the next target, then we'll have to reduce our total extra capacity by our total delta, but then we can set our current capacity to this new target. Then we increase our target and we move on. All right, so now we're slowly raising up all of our batteries to be the next target value. Now, if we make it through all of this and we get to the end, then we can return, let's see, what do we return? Well, we have our current capacity. So we've raised up all of our batteries as much as possible. We're at some current capacity. This could be the end of it, but what if there's still some extra battery capacity left? We might still be able to distribute all this extra battery capacity to all of the different batteries. So we can just redistribute whatever extra battery capacity we have among all of the batteries. So we have to divide this, again, it will be an integer divide, by n. So if we make it through all of this, we still have extra battery capacity, we'll just take that battery capacity and distribute it evenly among all of our batteries. So that's n batteries. All right, oh man, this is tricky. So I was going over the code, doing a little review here, but honestly, I was boring myself. So we're gonna skip ahead. We're not gonna go through the review, it's boring. So let's just jump to see if this works. We'll jump ahead, check it out. To the next battery capacity in the list. So to do that, you know what, I'm not gonna bother doing that. I'm just gonna run. Okay, and this works. Let's submit this and see how we do. And we pass. And let's see, how did we do? We do really well. We beat 98% for runtime and 45% for memory. So not bad. Actually, we do better than that. We do 98.8% runtime and 49.4% for battery. Battery, oh, batteries on the brain. Let me try that again. We beat 98.8% for runtime and we beat 49.4% for memory. So yeah, we do really well. Now, there's some things we could probably do in here to clean up some of the memory. Some of these names are really long. I'm not gonna bother. This is a hard problem. I suggest you try to do this one on your own. Just jump into it, take what you learned here, try to remember it, code it out, see if it works. If you ever have problems, you can always jump back in here, check out the video again. All right, that is it for me. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.